Hello. So in this video session I'm going to explain about asynchronous MOD-6 counter. So as per asynchronous counter, so in this case only one clock is connected externally to first flip-flop and second flip-flop is need to join to a clock, that is the output from a previous flip-flop. So that is known as asynchronous counter. So by this circuit diagram we are going to implement MOD-6. So first we check the truth table for MOD-6. So in this case, so this is the clock pulse and here we are going to show the outputs QA, QB, QC, QD, right? So counter is going to start from 1 and move till 6 or either 0 to 5, and your counting is start 0 0 0 0 0 0 0 1 till 6th value, and after this 6 it is going to return back to first, that is 0 0 0 0. Because this IC we are going to implement this MOD-6 by using 7490. So this IC is a BCD IC. So this counter, this IC is going to work for 9, 0 to 9. So that means this counter is going to show the outputs in continuous fashion from 0 to 9. But due to its title, it is MOD-6. So we want to stop this counting till 6 and after that we want 0 0 0 0. So as per actual IC, so your next output is 0 1 1 0, but we are trying to make it to 0 0 0 0 because we want to operate for MOD-6. So means on the 7th pin, 7th count, this value is going to 0 0 0 0. So for that we are going to use the concept of a preset. So means we are going to make these two outputs, because these outputs are kind of QA, QB, QC, QD. So we want to make these two outputs QB and QC to 0. So for that we press reset button, right? So that your counter automatically reaches to first location 0 0 0 0. So for that now we see the pin configuration or circuit diagram for MOD-6 asynchronous counter. So first pin number 5 VCC, pin number 10 ground, pin number 6 and 7 that are the set pins that are going to join to a ground, pin number 14 having a first clock, that is the external clock that we need to connect to first flip-flop, pin number 1 that is for clock B, that means that is the clock input to second flip-flop, but that is generally going to join to first flip-flop output, because second clock is always going to get the clock from previous flip-flop output. So these are the basic connections, and then the output connections are on first output on 12, second output on 9th pin, third on 8th pin and fourth on 11th pin. And after this we want to make it MOD-6 from total count 0 to 9. So for that we want to make this pins to reset, again reset, so to make it 0. So for that, so what are that values? QB and QC. So where is QB and QC? So according to a circuit design, we know if we are using AND gate to make that value of a output to 0, so that is possible. So for that we are going to use a AND gate to reset the counter, or we can say preset this outputs from 1 to 0. So that's why we are going to go for that two connections of QB to AND gate of 1, QC to AND gate of 2, and AND gate output is joined to be reset pin. So where are the reset pin? 2 and 3. Actually in this pin diagram 2 and 3 are actually on a ground, but we want to make these two pins are preset, connect to preset, means you want to reset it, activate it from 1 to 0. So that's why we are going to join this to AND gate output. So now we see all the connections on the digital trainer board. So for that, first we need to join a IC, that is 7490. This IC is a 14 pin IC. So we are going to connect this IC on a socket, first socket, and lock this IC. So this is the basic rule. Then we need to join a VCC and ground connection. So as per this pin diagram, VCC is on 5th number. So I'm going to go to 5th number. So ground, no, 5th is on VCC, and 10th. So we need to check where is 10th. So here is the 10th. So 10th pin is on the ground. So we complete these two connections. Now we are going to join the 6 and 7 to ground. So where is 6? We check the 6th pin. So here is the 6th pin. We need to connect it to ground. Then 7th pin is the 7th pin. So we finished this connection. Then we need to connect a clock. Clock is on 14th pin, and we are going to join the clock on a 14th pin to a clock section. So on this board, here is the clock section. So in this clock section, this is the manual and this is the automatic clock section. So we can use any one. So now we are going to use a manual connection for the clock. So this connection is over. Now we need to join this, or either we need to join a first second IC, that is 7408. So we need to connect that. Yes, and then we know its 7th pin is a ground pin, and pin number 14th of this IC is a VCC. So we made that two connections. Then we are going to join this outputs. So for output connections, we used this section, and from this section these 3 lines are there. We can use any one for our output. So suppose I want to use this one. So 1 output, 2, 3 and 4. So I have joined 4 connectors for connecting to 4 output pins. So first connection is for QA. So I have to join it to 12th. So we need to check where is 12th. So here is the 12th pin. So then next I need to check 9. So where is 9? So as per this circuit, here is the 9th pin. So connected. Then connection for 8th. So check. Here is the 8th. And then last connection for 11. So we need to check where is the 11th pin. Here is the 11th pin. So we've completed this connection, this connection, this connection and this connection, right? So now we are going to short this 2 and 3 connection. So first pin number 2, I am going to short this pin, or otherwise you can join both the pins to OR gate output. So where is the OR gate output? That is on pin number 3. So I can join 2 and 3 to OR gate output. So where is the OR gate output? I need to check. So here is the pin number 3. Pin number 3 of IC, first IC, is need to be joined to OR gate pin number 3. So we have completed this part also, this connection also. Now we are going to this. So first one is going to be connected to 9. 1 of OR gate is going to join to 9 of previous IC. So connection 1 of OR gate is going to join to 9th. So we need to check where is 9. So here is the 9th pin, right? So then second pin number 2 of a AND gate. So this is my AND gate. Pin number 2 of a AND gate is going to join to 8th pin. So we will check where is 8th pin. So here is the 8th pin. Now I think so we have finished all the connections for this board. This clock 1. So okay, clock 1 connection is still pending. So pin number 1, this connection, pin number 1 is going to be joined to pin number 12. So where is 12? So here is 12. Right? So now we have finished all the connections for this circuit. So now we are going to test it. For its testing, first I need to make a power on. So now power is on. So I need to check all the outputs counting till 6. So manually I am going to press this switch manually. So I make the clock connection here for a manual connection. So I am going to press this switch manually. So we check. So we need to check where? So on this point we are going to check 1, 2, 3, 4, 5. On 6th, your counter is reaches to 0, because in this case your clock start from a count from a 0. So it shows 0, 1, 2, 3, 4, 5. Right? So last value should be 1, 0, 1. So this is clear. You can check again. We can check 1, 2, 3, 4, 5. Right? So initially it's 0. So next count, initial count it's 0. Next count 1, 2, 3, 4, 5. So this is the case if you are going to work for mod 6. So same case here, if you want to make it mod 3, so means this connection. So in this case, your this bit should be equal to this connection should be equal to 0, 0, right? So similar way you can perform for any mod number by using 7490 IC. Thank you.